Okay, in this last video, I'll explain how to use the ecosystem function mapping scenario analysis tool. And just to go backwards for a minute to explain the kind of what's happening here. So in previous videos and reports, we've described how we went about mapping the different ecosystem types, which we're calling ecosystem reporting categories there. And we have 27 different ecosystem reporting categories, and we've aggregated up all of the individual 10 meter by 10 meter cells that contain the different ecosystem types, and here's an indication of the total spatial extent of each of those different ecosystem types. So for instance, you can see sclerophyll forests here, 47,305 hectares. Obviously a very large proportion of the entire area. Native and improved grassland, similarly 36,924 hectares, and so on. So it gives you a bit of an indication then about the relative size of each of the different ecosystem types. Now, please note that the total area here, this 244,598 hectares, is more than the actual Sunshine Coast local government area boundary, the formal one, because it also includes ocean areas up here and so on that you can see. Okay, in addition to mapping out those areas, the ecosystem types in hectares, we also went about mapping the functions in hectares. So that's requires a bit of explanation here to talk about how we would go about doing that. So you can see here, for example, we estimate that there is 159,564 hectares of the entire Sunshine Coast region that is performing, that is fully performing that GAS function. So the way that we've gone about doing this analysis is to go back to the scientific expert panels, which is the scoring method which relates what is the performance of each ecosystem function within each ecosystem reporting category. So you can see here, for instance, for gas regulation, and the top one here, that gas regulation is being performed at a 4 out of 5 level in that pelagic zone. Whereas, it's being fully performed in the shrubland or woodland area and hardly performed at all, 1 out of 5 in hard surfaces. So what we've done then to get a full spatial extent of the gas regulation is to use these scores then to, I don't know if you call it standardize, but to kind of calibrate each of the different locations based on the performance of the function that's occurring within it. So there's two separate ways of kind of looking at this. Rainforests, for example, are performing that gas regulation function at a level of 5, and that's what we're interested in, is fully performing equivalent hectares. So any hectare of rainforest in our analysis then, in this particular tool, this scenario analysis tool then, would get, if it's a hectare of rainforest, it would get a fully performing hectare associated with that particular ecosystem type. Whereas if it were, for instance, if I look at rocky shores, which is only 1 out of 5, well, a hectare of rocky shores then would only count for 1/5 or 20% of a hectare of the full performance of that function. In other words, it would take 5 hectares of rocky shores to equate to 1 hectare of rainforest. So we're converting everything, if you will, like currencies. We're converting everything into fully performing hectares. So I'll show you that now in the scenario analysis tool. Okay, so this is also available up on the website, and you can use this, as we have done, to investigate different land use change and climate change scenarios. So on the upper left here, we can see the different ecosystem reporting categories all through here, as I've just shown you in those previous slides, and the baseline hectares that we're using. You'll notice some are undefined there, and we have explanations for that here in the spreadsheet and also in our methods video. Okay, so what we're interested then is, first of all, a bit more of an explanation then about how we calculate these different total hectare values of the functions themselves. Obviously, the hectares of the ecosystem types are quite straightforward. So here, for instance, let's look at gas regulation in the pelagic zone. So we can see that the total size of all of the combined different cells that we're, mapping, the total size here is 3,358 hectares of that pelagic ecosystem type. But over here, you can see that that associated gas regulation is less than that. So that is because the score for the performance of gas regulation in that pelagic ecosystem type was a 4 out of 5. So essentially, we've used that ratio, 4/5, to make an equivalent fully functional hectare size there. So that then in turn is 2,687 fully functional equivalent hectares of that function. So we do that same multiplication of the expert panel's performance score against the total hectares of that ecosystem type, and that gives us our hectares of the ecosystem function that is being performed spatially. Okay, so then you can actually go into the spreadsheet and see for each different ecosystem reporting category what the equivalent fully performing hectares of each of the different functions are in here, and what the spatial extent of the coverage of the Sunshine Coast that represents. Okay, so the scenario tool itself then has a further purpose, and that is to investigate different possible land use change scenarios. And maybe they're because of development, or maybe they're because of climate change and so on. But it's worth considering, not only the kind of traditional view of what types of ecosystems would be lost under those different scenarios, but in this case, what kind of functions will be lost when an ecosystem is converted from one type or category to another. So let's just, as an example, say we're interested in, let's say we've got rainforests, and we're interested in investigating some scenario around loss of rainforest and its conversion into something else. So what we do here is we have our baseline hectares here, and then what we're going to do is introduce some change, plus or minus change in here of those hectare values, and it's going to produce some new scenarios in terms of the overall size of those ecosystem types. So let's go back here to rainforest and say, let's imagine we lose 5,000 hectares of rainforest. I'm going to do a minus 5,000 in that particular location. Now you can see these areas no longer line up, so I need to actually also enter in, well, what did it become? If it wasn't rainforest, what happened to it? So let's imagine some of it perhaps changed into a different ecosystem type, maybe because of climate change, it changed into perhaps a shrubland, woodland environment instead. So maybe I have, an increase of 1,000 hectares of that particular ecosystem type. Perhaps part of it was maybe converted into sugarcane. Let's add 500 hectares of sugarcane there. Let's imagine some of it was developed into roads and other hard surfaces. So we're going to add maybe 250 hectares there. You can see I still have 3,250 different hectares to reassign somewhere. Let's imagine that some of that were to go into parks and gardens. So we'll add 1,500 hectares there. We still have some left, and let's imagine that that were to go into other irrigated crops. So we'll just put 1,750. Obviously, this is a totally made-up scenario, but you can imagine your own scenario and then investigate it here. So what we're interested in now is you can see that the total hectares are now equal between the baseline and the scenario. We lost 5,000 of rainforest, and it was converted into other types of ecosystem categories. So that now, this first blue table at the top here shows the original baseline equivalent hectares of those functions. The revised one here now shows what the scenario is, that new hypothetical scenario that we just put in there, and the changes in those functions, right? The changes in their spatial extent where they occur. Perhaps of most interest is this lowest table here, which shows the change in the equivalent hectares from that baseline to the scenario. So here, anything in red represents a loss. So you can see right away all of the red cells here, and in fact they're gradated, if you will. They have a color gradation with a greater and lesser loss. So that would be, what this is saying is that there's been a 5,000 equivalent hectare loss of the gas regulation function as a result of that loss of rainforest, partly made up here by a 1,000 hectare equivalent increase in the performance of that function in shrubland, woodland ecosystems, a little bit occurring in the sugarcane, a little bit occurring in other irrigated crops, and practically nothing in hard surfaces, and then another 600 hectares of equivalent function occurring in the parks and gardens that we put in there. But notice overall here down at the bottom of that gas regulation, overall, as a result of that land use change, that loss of 5,000 hectares of rainforest into these other categories, we lost 2,450 equivalent hectares of that gas regulation function. And you can see, similarly, we lost 3,000 hectares of the climate regulation function, and that's kind of microclimate function, if you will. The microclimate that, resulting from forest environments and so on. We lost 3,050 of disturbance regulation and so on. So you can see that, losing rainforest is really consequential because it's such a high functioning ecosystem type. If we were to lose hard surfaces and put them back into some other category like native and improved grasslands, we would be gaining ecosystem functions almost certainly. Okay, so that's the scenario analysis tool, and gives you some ability to investigate your own scenarios. What would happen if, X lot was developed that's currently in a natural state, or climate change occurs and changes the nature of ecosystem types and so on. So this is really a tool for advanced users and academics to conduct research, and we hope you find it useful.